Hi, we're here on the engineering campus at the University of Illinois. We're inside the Material Research Laboratory to talk with Professor John Rogers about his fascinating work on wearable electronics.
The Rogers Research Group consists of over 40 students, undergraduates, graduate students, and postdoctoral students who are conducting research on nanomaterials and their applications to electronics. So some of the interesting projects that they're working on right now include dissolvable circuits and 3D printed electronics, all of which have really interesting implications for digital marketing.
Did you say dissolvable circuits?
Yes, I did.
Let's go find out more.
All right.
John, thanks for visiting with us today.
Yeah, thanks for having me.
Can you tell us a bit about the work that you're doing in its applications?
Yeah, sure. So I'm an electronic materials scientist, so we're interested in new kinds of materials that can be used for integrated circuits or semiconductor devices, various types, sensors, and so on. And one of the areas that we've been focusing in on over the years is trying to adapt electronics to enable sort of highly intimate, highly functional interfaces with the human body. If you think about consumer electronics that exist today, it's largely planar and rigid and brittle in its construction, and that's a reflection of the fact that all integrated circuits that have ever been built and sold commercially have been formed on the surfaces of semiconductor wafers, which essentially have the properties of a plate of glass, so very thin and brittle. And that's great for a cell phone. You want to put it in your pocket, you don't necessarily need to bend it. But if you want a highly functional interface to the human body, you need a whole different set of geometrical and mechanical properties, because the skin, the heart, the brain, I mean, they are contoured surfaces, it's soft materials. And so we've been working on how to configure electronic devices generally to enable that kind of interface with the body, with the idea that a successful outcome in that direction could really profoundly change the way we think about human healthcare.
So I know you mentioned that these things could lower the cost of healthcare.
Yeah.
Is it because the materials are cheaper? How does that work?
Well, so there is a cost to the device, right? So not everybody's wearing a health monitor right now. I mean, we think that's a vision of the future. So at one very basic level, you would say, oh, that's increasing the cost, because now everybody has to buy a health monitoring patch they didn't use before. But the idea is that if you are wearing this health monitoring patch, it allows you to catch disease states far earlier. And so it allows preventive care that has a huge beneficial impact on the cost, because the procedural costs are not so high if you catch it early. So that would be the rationale. It's a relatively modest upfront cost, but a huge benefit down the line in terms of overall health.
John, you hit on I think, a really interesting point, which is a theme in our course, that we've seen through this digital revolution that the tools that were once held by the few and that were very large and expensive are now available to the many, are smaller and much cheaper. And as a result, we're seeing consumers, and perhaps in this case patients, taking more control in the marketplace. And can you speak about that a bit, how that might change the nature of the healthcare marketplace?
Yeah, so it's an interesting question. I don't know exactly how to predict the future of this. One school of thought is that these devices will allow you to personalize your health, and so you will have access to all this data, and you can sort through it and figure out how to modify your diet or exercise more or less. You can figure out if you're sleeping well and getting enough sleep and so on. I don't know that sort of mindset is widespread in society. My guess is probably not. That most people, even if they had access to the information, might not be sufficiently motivated to track it and understand it and study it and try to do behavior modification based on that. There will be some fraction, but I don't think that's the majority of folks out there. I think that these devices are most valuable when they're coupled with an informatics and sort of a big data system that can automatically sort through a lot of this stuff, reduce all of these complex data streams to meaningful initial diagnostics, right, that can then be evaluated by a healthcare professional, and then that feedback comes back to the individual. So in some ways it becomes invisible, right? Not only is the device mechanically invisible in the way that it integrates in the skin, you forget about it, that it's even there, but you don't even have to worry about the data, because that is being processed and handled and analyzed by somebody else, and there will be computer algorithms to help with that.
So in the future, perhaps, when I wake up and I'll have my health monitor tattoo, I log in and I'll see a green, you have to go today, versus a yellow, perhaps call your doctor, and the red, go to the hospital.
Yeah, maybe you don't even have to log in. It'll send you a warning, send you an email or something like that, just to make it as transparent as possible to the individual, because people are busy, they're not going to have time to study all these data streams coming out of their patch, right? Yeah, I think lots of people are going to want access to this data. Insurance companies, for example, they might want to know it because they can develop a profile of an individual's health and then set premiums, on that basis. But there's a lot of benefit for them to encourage their customers to be wearing these things, right? Because it has the effect of minimizing the overall liability that they assume if somebody gets sick. So I can imagine that ultimately, from the business side of things, the insurers might be paying for all this stuff, right? Because it would be a good investment for them to do that.
Okay. If I can just take you on a bit of a divergence to think about. Your focus is on the healthcare applications of this technology, but how about other non-healthcare applications? For example, having a patch that would detect my behavior at an amusement park.
Yeah,
for example.
Yeah. So we work with a number of large companies in that space, and exactly for that reason, to facilitate transactions. They want to make it as easy as possible for visitors to the theme parks to buy stuff, right? So if patches like this provide that kind of capability, they're interested in it. And so we have ongoing interactions. I probably shouldn't mention the name of the company, but we did a field trial with them. Hundreds of devices launched at a Halloween event at one of their theme parks back in October. So most definitely there are applications in that space. We also have funded relationships with large cosmetics companies, sort of monitoring the properties of skin and using that data to inform customers as to what kind of cosmetics or what kind of creams or what kind of sunscreen they should be applying and when, right? Devices that monitor pollution or exposure to environmental toxins or chemicals are another example of how you could use this stuff.
Could you, I know your time is limited, but say anything about the broader sort of digital marketplace where you see things happening beyond your scope of research? Or like 25 years from now?
Yeah, I think there are a lot of interesting things happening in display. I mean, I think you see computer systems getting more and more sophisticated. The interface to the human is still fairly primitive, right? It's just a flat sort of 2D picture. I think there's a lot of things that are happening that are interesting in the 3D space beyond what's there today. And I think sort of human-machine interfaces are getting more and more sophisticated. So not only prosthetic control, but computer game control, just interfaces between the human and the computer, right? The digital system. I think there are a lot of things happening in that area. Neural-based control of machines is a very exciting space as well. And I think a lot of that is going to be driven by new software, new algorithmic approaches, but also new hardware as well.
So what we have here is a neonatal isolette that's used typically in hospitals. We've used this to highlight some of our current device technology. Inside, we have our baby that typically in a neonatal isolette would have many wires and cables, anywhere from 3 to 15 sensors, depending on the severity of the situation the baby would be in. And we've been able to make wireless sensors that worked off inductive coupling technology. And we have a sensor on the baby's foot, on the midsection of the chest, and also on the head. While the baby's in the isolette, it's able to move freely and is not constrained by any wires or cable. And all the vital signs of the baby can be monitored via the computer remotely. During the fabrication of many devices and sensors, some of the atmospheres that the device is exposed to are very critical to their operation and fabrication process. The glove box behind me is a controlled atmosphere glove box that doesn't allow any air to be exposed to the device during this process. So some of the devices that we develop have to be fabricated and encapsulated in this type of atmosphere.